All right, I apologize for the weird noises you hear coming from the background. That's just my children being normally weird. So the top of this slide says we are looking at the graphs of cosecant and secant. We're specifically just going to look at cosecant and tangent today, but notice how they're in the similar format as the sine and cosine, and these are both reciprocal functions. And just a reminder of the reciprocal functions, we have them listed here. And anytime you're dividing by a value, you have this risk of having a function having 0 in the denominator. And I don't know if you remember the term for that, but when you divide by 0, it's undefined. And we're going to look and see how that affects these graphs. So again, these are just reminders of the reciprocal functions, both when you're just relating them to another trigonometric function and when you're looking at the actual values from the unit circle. Okay. All right, so we're just looking at cosecant. And if I went around the unit circle, here are my values for sine. And then here, because cosecant is the reciprocal, here are my values for cosecant. And notice where you have 0 for sine, I have this dash. That's because it's undefined there. Thinking back to rational functions, we would set the denominator equal to 0 to find the vertical asymptotes. And so anytime we have an undefined portion, that's where my vertical asymptotes would be located. So we're going to have a vertical asymptote at 0, one at pi, and another one at 2 pi. And then all these values would have helped you come up with the shape of their graph. But actually, cosecant and secant were pretty easy to graph. Like the way we learned them was we graphed our sine graph, and then we drew our parabolas because that's what they end up being at each of the peaks, whether it's a max or a min of the sine. So notice what cosecant looks like. Notice we said we would have a vertical asymptote at 0. Said we'd have one at pi and at 2 pi, and we do. And so that's what separates these separate sections. So only the red graph here is your cosecant graph. The blue graph is the sine graph, and it's showing the relationship between both of them. So in this case, our domain is not all real numbers. Our domain is going to be like, it's going to be all real numbers except intervals of pi k. And we can just say k is like the amount of intervals. So everything except for every pi values, notice there's a vertical asymptote. Our range is going to be -infinity to -1 or 1 to infinity. We don't have a y-intercept, so that's not applicable. There are no x-intercepts. And the period is going to be the same as the sine graph. So the period is 2 pi. That's period, remember the definition is completing one cycle. And one cycle includes the positive parabola and also the negative parabola. Right. So secant, if you can imagine the secant graph, it is the same as this, except for it is bouncing off the mins and maxes of cosine. That's the only difference. All right, here's lots of notes. We just kind of talked about this on the previous page, but if you want to take a moment and get those notes down, this is information about secant and cosecant. All right, now let's look at tangent. And so remember that tangent is a ratio. It is y over x from your values on the unit circle. So this graph just pretty much shows how they went through and they got all these values at tangent at different values. And then they put them on their graph over here. And notice the graph has two vertical asymptotes. So the range in this case is all real numbers. But again, tangent, it completes one cycle between negative pi over 2 and positive pi over 2. And so the vertical asymptotes from that, it's going to be all real numbers except, and this is weird, negative pi over 2k or a positive pi over 2k, because that is where all your vertical asymptotes are. And the period is not 2 pi, so tangent, it kind of does its own thing, and so cotangent would as well. Tangent actually has a period or one cycle of just pi, so negative pi over 2 to pi over 2, this is 1/2 pi plus another 1/2 pi, that's just pi. So the period for that is pi. Now if you wanted to talk about cotangent, cotangent being the reciprocal of tangent, cotangent's graph, just do the opposite. That would be cotangent of theta there. All right, last but not least is some important information about tangent. So remember, we could find for sine and cosine, and same with cosecant and secant, we would find the period by saying period is 2 pi divided by b. But notice it's different for tangent. Period, because the period isn't 2 pi to begin with, is going to be pi over b. And these negative pi over 2b to a positive pi over 2b, those are vertical asymptotes. And then A, the amplitude, you can't see it as much like you can with cosine or sine. It stretches your graph, so it makes it more like a line. Or if it's a fraction or a decimal, then it makes it more curvy. So something like if I'm stretching it, it's going to be like that. Or if I'm shrinking it, it's going to be more like that. And we've had some functions that have done that in the school year. All right, so here's what a tangent actually looks like. This is actually 1/2 tangent x. So our period is still pi, and we can see that here, negative pi over 2. Well, pi over 2 all the way up to 3 pi over 2, that is one period, and that's equivalent to pi. And the way that we would see the stretching is if I was doing the parent function, which I don't know if you guys can see, that there's like this little dash line here. Maybe. This dash line is the parent function. So the parent function is just tangent of t. Its amplitude, instead of being here at 3 pi over 4 and negative 1/2, it's going to be 3 pi over 4, and this is going to be a negative 1, and up here, this is going to be a positive 1. So that's the difference between the parent function and something in this case is compressed, or they said shrunk. And that's all I have for this. There is a Google form that goes with this, and you're going to want to go and click on it, and it's just simple 3 questions. What did you find interesting? What did you learn? And what would you want to know more about, depending on the math or just your curiosity going into. So take the time and go through that. Thank you.